Hi, hi, Kristen. Just you so far. Did you fix your audio problem? I cannot. Can you unmute yourself?
Okay, let's try that.
Okay. I heard you. That's great.
Good.
What happened to this class? It's weird.
I'm not sure.
Hmm. Thank you for coming.
Not a problem. I enjoy class. It's just one of those things. Got to do it.
Let's give it more time. It's 1 o'clock. Hmm. I'll wait for 1 more minute, okay?
Okay.
And then record attendance. If it's
o-
just us, then I'll help you to do your homework assignments. How about that?
Okay. Sounds
Hmm.
good.
This never happened. I mean,
It's
I'm not sure
different.
are they aware they're enrolled in the class and this session is has meetings.
Yes.
All right, let me record attendance for today. The only one present is Kristen Miller. Absent, absent, absent. Save. Okay. So I'm going to stop share. I'm gonna let you to share. Let me
Okay.
fix the sharing setting. Share setting. This one. Post. All right. Yeah, try to share your Blackboard and we're gonna work on helping your assignments, okay?
Okay.
Oh, do we have one more student? Hi, Brandon.
Hello.
Do you have a camera?
Yes, I do.
Okay. Very good. Thank you for coming.
Of course. Did you want me to
Um,
turn my camera on?
yeah, if it doesn't bother you, I'd like to have have the camera on. So
Okay.
our only Kristen is here, so
Hello.
going to share her homework assignments. Um, since now we have more than one student, would you like me to share and then we look at the first two sections homework assignments they are going to do on Sunday?
Yes, that would be great.
Okay, then I'm gonna share. Okay, and you let me know if you have any questions. This question I
I
need help,
will.
and you let me know. And also I need to fix the attendance. Brandon. Brandon, is that you email me saying that you just come back from traveling?
Did we lose Brandon?
It's Brandon, right?
Oh, sorry. Yeah, that was me.
Oh, okay. All right, very good. Cool. Let's go to Lumen. This is section. Yeah, I would like you to look at your Blackboard as well. So we're gonna start with section 1.1. The definition of function. Okay, not this one. Excuse me. It's practice this one. All right. So what is a function? Function is a set of ordered pairs. For any given x, there's only one corresponding y value. So let me explain the definition of function by using this example. All right. So those are three relations. Relation. It's good to know this definition. Relation is a set of ordered pairs. Any set, if the elements in the set are ordered pairs, then that set is a relation. For example, this is a relation because we are able to write the information in the table as a set of ordered pairs. The first pair, 1, 2. Okay, I'm using the value of x as the first component, use the value of y as the second component. And then we also have 6, 8, 15, 8. So this is a set of ordered pair. So it is a relation. Same way the second table. The second table also gives us a set of ordered pairs. If we write it down, we have, I was using blue, right? This one. 1, 2, 6, 8, 15, 12. The third one is also a set of ordered pairs. We can write the first pair as 1, 2 when x equals 1, y equals 2. Second pair, 6, 8, 6, 8, and then 6, 12. All right, so now we are looking at three relations. Not every relation is a function. One condition has to be satisfied, okay? One condition has to be satisfied for that relation to be a function, okay? It's just like female are human being, right? Are humans. But not every human is a female. You see the relationship here? Only certain characteristics or conditions are met, then we say that human is a female, right? Female, of course, is a human, but human is not necessarily has to be woman. I think it's better to write here as a woman. Yeah, women are human beings, but not all the human beings are women, right? Certain conditions must be met. Same with functions and relations. Function is a relation, but not all the relation is qualified to be a function. And what type of relation can be a function? Yeah, one condition means for every x, there is only one, exactly one y. Okay, that means for each input, there's only one corresponding output. We explained that concept on Tuesday, right? Well, let's look at the three relations, okay? Let's use the machine input output to analyze. The first one. When you give the machine input 1, x is the input, y is the output, right? You get an output 2. When you give the input 6, you get an output 8. When you give the input 15, you get an output 8. So we can actually combine the last two as when you give the machine 15, 6 or 15, you will have the same output 8, right? But this does not disqualify this relation to be a function. In fact, this is a function, okay? Because for each input, there's only one corresponding output. And I want to know if I am clear. So we have three participants now. Emma is here. Hi, Emma. Hi.
Sorry, it took me a while to log in because I was trying to work their TV and disable it.
I couldn't hear you. Sorry. Yeah, I'm going to fix your attendance. All right. I will fix that attendance later. So am I clear about the first relation? The first relation is a function because for each input, there's only one corresponding output. For each input, there's only one corresponding output, right? For each husband, there's only one wife. Now let's look at the second one. When the input is 1, output is 2. When the input is 6, output is 8. When the input is 15, output is 12. Yep. For each input, there's only one corresponding output. So this one is also a function. The last one, let's see. When the input is 1, output is 2. When the input is 6, output is 8 or 12. Oops, that disqualifies this relation to be a function. So among the three relations, there are two functions. The third one is not a function because the condition is not satisfied. For the input 6, there are two different outputs. That is not allowed for a function, right? Because by the definition, in order to be a function, for each input, there can be only one corresponding output. For each husband, there's only one corresponding wife. And maybe Brandon has no idea what I'm talking about because he wasn't here on Tuesday. Brandon, let me show you how to watch the video that you missed on Tuesday. So if you go to our course shell and click on Zoom meeting, this is where you join the meetings, right? But look at the menu right here. Do you see cloud recordings?
Yes.
When you click on cloud recordings, you will see the recording from Tuesday, August 18th.
Oh, okay.
You can download the video. Yeah, you can watch the recording. Yeah, we covered the concept of function. So I use an analogy, husband and wife. That was actually from Monday. All right, guys, am I clear about the first question? So there's only, the first two. This one's a function, this one's a function. Kristen, am I clear?
Yes.
Okay. Emma, am I clear about this problem?
Yes.
Okay, very good. Thank you for your response. Very good. And then first, let's look at the second question. All right, and you can tell for -10, the output is -9. For -9, output is, how many outputs?
There's 2.
Yeah. So if I use the machine to run the input output, you'll see what's going on. Hold on. Right here. Yeah, it has 2 different outputs, right? Yeah, for this relation, this is a relation. Any collection of ordered pairs is a relation. This relation is not a function. Yeah, Kristen already see it, because when we feed the machine input -9, the first component is always input. The second component is output. So when we give -9, we have 2 different outputs, right? And that would disqualify this relation to be a function. This is not a function, all right? This is not a function. It's very important, very basic. Next question is to evaluate a function. Evaluating is very basic, but also very important. Even you go to pre-cal, okay, you probably do not go to pre-cal. Higher level mathematics like calculus, and you always need to evaluate expressions by plugging in, right? Yeah, the technique we apply is called plugging in. Let me show you how do I plug in. Okay. So here, f of x is a function. The function is 6x squared plus 3x plus 6. Okay. And if we write f of x as y, then the equation is y equals 6x squared plus 3x plus 6. Okay? Y here is f of x. It's the same thing. F of x is y. F of x is the y value when the input is x. Okay? When the input is x, the value of y, the function, the value of y. Yeah, y is the function. So f of -5 represent, this is the value of y as x equals -5. Remember, y depends on x, wife depends on husband, y is dependent variable. The value of y depends on value of x, right? So in order to find f of -5, we need plugging in x equals -5. Okay? Yeah, because this notation means the value of y when x equals -5. So all we need to do is just plug in. We use parentheses to hold a place for x, and we're gonna put -5 in the parentheses. Okay, and I want you to evaluate this blue part for me. I want you to tell me the value of that blue part. The blue part is 6 times parentheses -5 to the power of 2.
With 90.
How do you get a 90?
I don't know.
Okay, so do you guys remember PEMDAS?
Yes.
Right?
Parentheses, exponents, multiple to this.
Yeah,
And
exponent first, right? Should we do
Yeah.
the exponentiation first?
Yeah.
Yeah, so we do the exponentiation first. -5 to the power of 2, -5 times -5,
45,
25. Yeah, 25 times 6,
150.
150, exactly. Do you agree, guys?
Yes.
Mm-hmm. All right. And 3 times -5 is -15, right? And plus 6.
Correct.
Mm-hmm. All right. So when the expression only has subtraction and addition, we go from the left to right. Okay, let me write down the rule. There's a misunderstanding here because PEMDAS has addition in front of subtraction. So some students misunderstand you have to do the addition always first, not necessarily, okay? Yeah, when the expression only has addition and subtraction, you go from left to right. Let me write it down. When an expression only contains addition and subtraction, you do not have multiplication or division or exponent, only addition and subtraction. The order is we go from left to right. Go from left to right, okay? This is a good example. Let me color this part as green, okay? Yeah, this expression only contains addition and subtraction, but we do not do the addition first. Instead, we do the subtraction first because from left to right, we see the subtraction first, right? When we read a book, do we go from left to right? When we read the information, the article on the internet or cell phone, you go from left to right, you don't do the other way around, right? Okay, so we see the subtraction first, we do the subtraction. 150 minus 15, 135, you can use your calculator, and then plus 6, that gives us 141. Do you agree?
How's it 141?
Did I make a mistake?
No, I did
Yeah.
my math wrong.
Yeah, it's 141, right?
Yeah.
I see Noah join us. Did we? Oh yeah. Hi Noah. Thank you for coming.
Yeah, sorry for being late.
Oh, it's okay. Thank you for coming. But next time, come here at 1 because I was confused. Where's everyone? Very good.
Yes, ma'am.
Yeah. All right. Let's continue. Let's see. I think I want to cover this problem. I see something yesterday. Yeah, this one. Question number 10. Okay, this is a good problem. It's a challenging one. Since we just covered question number 2, and this one actually is a similar problem but more difficult. Yeah, this is a similar problem but more difficult. Let's cover this problem. It's question number 10. The given function is actually linear, but you don't have to worry about that. G of x equals 6x minus 4. So this is the given function, right? And this function tells us the machine, when you give the machine, the function is a machine, right? When you give the machine input, okay, the output is 6 times input minus 4. Okay, I give you a little bit of time. Do you agree? So this equation defines a function, okay? Yeah, we can totally, for sure, we can write a function as y equals 6x minus 4. X is the input, y is the output, right? So this function defines the relationship between the two variables based on the function is the output is 6 times the input and then minus 4. Do you agree, guys?
Yes.
Yeah. For that machine, the specific machine G, the output is always 6 times the input and minus 4, okay? Yeah. So that's how do we understand the function. The function is y equals 6x minus 4. X is the input, y is output. So for this specific function, its output is always equal to 6 times the input and then minus 4, okay? Yeah, we need to look for the following outputs. Yeah, they are outputs. First one, G of 0. G of 0 is output, okay? It is the y value when x equals 0. In other words, this represents the output when the input is 0, okay? Yeah, so all we need to do is to plugging in x equals 0 or input equals 0, right? Remember the output is always equal to 6 times the input minus 4 for the specific function that is given g, right? And 6 times 0 is 0, 0 minus 4 is -4. Am I clear, everyone?
Yes.
Okay, next, G of 2, okay. And G of 2 is the output when the input is 2. Yeah, remember the output is always equal to 6 times the input minus 4. So you just plugging in x equals 2, right? 6 times 2 is 12. 12 minus 4 is 8. Okay? Next, G of -2. Similarly, right? G of -2 is the output as the input is -2. So the output would be 6 times the input. In this case, the input is -2 and then -4. 6 times -2, -12, and then -4 is -16. Next, yeah, that one, the last two are challenging parts. G of x plus 1. Okay. All right, I'm going to use the color, okay? Yellow. This notation, G of yellow, represent the output of the function when the input is yellow, okay? Is yellow. Okay, so yeah, the input is always in the parentheses. So we're gonna see the yellow as a whole thing, one whole thing. Then the output would be 6 times the input. Remember the input is yellow, and then -4, and then -4. Okay, and what is the input? What is yellow? And yellow is x plus 1. Do you see it? G of so I'm sorry. Go ahead.
Don't we multiply the 6 to both the x and 1?
Oh yeah, we do. But so far, do you understand the steps?
Yes.
Okay, very good. And
Yes.
now we distribute, right? Yeah. 6 times x, 6x. 6 times 1 is 6 minus 4. And we have 6x plus 2. Yes, we do have to simplify. We want to simplify it. So far, so good?
Mhm.
Yeah. Next one, the last one is g of -x. G of -x. You know what? We don't have to worry about what's in the parentheses. Whatever in the parentheses, that's the input. We do need to know for this specific function g, the output is always equal to 6 times the input and then -4. That's what we need to do. We need to know. And in this part, the input is the yellow, okay? Yeah, the input is -x. So just to put a -x in the yellow, okay? So the output of the function g, when the input is yellow, in this case, the input is -x. So the output would be 6 times the input and then -4. Positive times negative gives negative, right? So 6 times -x is -6x and then -4. And that's the answer for the last part. If you understand this part, you have the abstract thinking ability. It's quite important. If you understand this problem, you can learn calculus for sure. All right? Any questions so far? All right. Any questions? No response, and I'm going to continue. All right. Let's look at the graphs. All right. This is the graph. This is a graph. Question number 4. Let me make this graph bigger. Let's look at number 4. All right. So firstly, I want to explain or give you a conclusion. Any graph in the rectangular coordinate system, RCS represent rectangular coordinate system. Any graph in the rectangular coordinate system is a relation. Okay, I don't mind to repeat the definition of a relation. A relation is a set of ordered pairs. I can write it down again. A relation is a set of ordered pairs. Okay. What's the reason any graph in a rectangular coordinate system is a relation? Because, for example, I randomly draw a graph like that. Okay, and the graph has many, many points, right? Do you agree? Many, 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 many points. The reason we have this curve is because of the points on the curve, right? And each single of the points is a ordered pair. So this one is an ordered pair, maybe -1, 2, right? And this one is an ordered pair, maybe -0.9, 2.1, right? So those points, any point in a rectangular coordinate system is an ordered pair. So the curve, the graph, is just many, 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 many points put together. So the graph is many, many, many ordered pairs put together. Since relation is a set of ordered pairs, the graph is a relation. Please let me know. Am I clear?
Yes.
Okay, so relation is any graph is a relation. You should include this conclusion in your note. You should have a little notebook for each course, right? Yeah. So this is an important conclusion. Any graph in a rectangular coordinate system is a relation. But not all the graph is a function. What kind of graph is a relation? Is a function, sorry, it spoke. When a graph passes the famous vertical line test. Yeah, if we have a graph, if a graph passes the vertical line test, then the graph not only a relation but also a function. Then the graph is a function. Okay, if a graph passes the famous vertical line test, then the graph is a function. Let's see this graph. Yeah, let me explain what is the vertical line test. So you just randomly draw a vertical line. If you do not see any vertical line pass or cross the function more than once, the graph more than once, then the graph passes the vertical line test and it is a function. Otherwise, it is not. Okay, let me show you more examples. Okay. The vertical line test. We can read the vertical line test definition here. Imagine placing a vertical line anywhere on a graph. If every vertical line touches the graph at most once, no more than once, then the graph is a function. Otherwise, the graph is not a function. We can look at this here. Okay, it's a little bit small. Let me see, how do I make it bigger? This way. Okay, so on the very top left, the graph is a horizontal straight line. You can try to draw a vertical line. You will not have a vertical line passing through or cross the graph more than once. Therefore, this graph is a function. And let me know if you understand, okay? Yes? Do you agree this graph is a function?
Yes.
Okay, let's see the one below that. Let's see this curve. Pretty complicated, right? For this curve, it is so easy for us to just find a vertical line that crosses the graph more than once. Like the one I draw here has 3 different intersections with the graph. Then this graph is not a function. Okay? Then this graph is not a function. It fails the vertical line test because those 3 points, they have the same husband, different wives. Okay, they have the same X, different Y. The one on the bottom, this curve, you can tell there is no vertical line touch the graph more than once. So it passes the vertical line test and it is a function. The one on the top right, the slanted straight line, will pass the vertical line test, right? Because there's no vertical line cross the graph more than once. So it is a function, it's a linear function. Yeah, we'll talk about that later. And this circle, very easily we can find a vertical line cross the graph more than once, twice, right? So it fails the vertical line test. It is not a function. And this sine curve is a sine curve, passes the vertical line test, and it is a function. And I want you to tell me, am I clear enough that you know what vertical line test is, and when do we use it, and how do we use it?
Yes.
Yes.
Okay, very good, perfect. And then let's go back our problem here. We have a curve, right? And we are looking for f of -3. We are looking for f of -3. Let me move the graph here. We mean to have those things together. Okay, let's look at this graph. We're looking for f of -3. Okay, what is the f of -3? It's important to know f of -3 is the y value when x is -3. So this question gives us function. You can use the vertical line test. It passes the vertical line test. It is a function. So let's see. The input, it tells us the input is -3, right? It tells us the input is -3. We are looking for the output. So that's what we need to do for this problem. It gives us a function. It gives us an input. We need to find the corresponding output. Okay, the notation, again, f of -3 is the output when the input is -3. We know input is x, output is y. So we're looking for a y value when x is -3. Yeah, y value depends on x. So we want to know what's the y when x is -3. In this case, the function is given as a graph. So we need to look for x equals 93. Where is x equals 93? Let's see, where's x equals 93? We look at the horizontal scale, right? X equals 93 is right here, right? X equals 93. And which point on the graph whose x value is 93? So we go down. Do you agree this point has the x value 93? The red point.
Yes.
Yes, okay. Then can you tell me what is the y coordinate of that point? It's a little small, right? I had to use my magnum, is -1 or look at the red point.
Looks -2.
Yeah, 92. Do you agree? Yeah, let's look at the red point. Let's look at the red point. Let's say the red point is A. Yeah, look at the point A. Let's find its coordinate. Its x coordinate is -3. Because the red point is 3 units to the left of the origin. Yeah, where's the origin? The origin is right here. This is the origin. Okay? Yeah, we're looking at the red point. The red point. The red point is 3 units to the left of the origin, so x is 93. And the red point is 2 units below the origin, so y value is 92. This pair is an element of the function, right? Is a input output pair of the function, and it tells us when the input is 93, output is 92. Let me know if I am clear enough about this problem.
Yes.
Yeah, there's no equation we can plug in. The function is given as a graph, so we need this is how we find the output. Okay, yeah, remember x is the input, x value is the input, y value is the output. Okay, yeah, let's continue. And this one is similar. Okay, yeah, we can do this one. The first part is to find f of 7. Output or input. So the first part, are we looking for output or input?
Output.
Output.
Yes, exactly. We are looking for output. Do we know the input? Because output depends on input, right? What's the input?
7.
1.
Yeah, 7. Remember, x is input. When x equals 7, what's the output?
1.
Look again.
45.
Yeah, 45. Okay, x. Yeah, x is input, right? Yeah, when x equals 7, output y, f of x is y, is 45. Very good. All right. The second part is different. The second part tells us f of x is 3. Remember, f of x is y. So we are given a value for y. So we know an output is 3. We want to know which input goes through the machine and gives us output 3. Do you see it?
8.
So
8.
8? Yeah, it is 8. Very, very good. So the output is 3, so we look at the second row, right? Yeah, when y equals 3, the input is 8. So let's do another one. Let's see. -69. -69. Yeah, this one. So this problem has two parts as well. Okay, let's do the first part. K of 4. How do we understand 4? 4 x. Okay. So what is the K of 4?
Negative 20.
Perfect. Second part, be careful, okay? Second part tells us K of x is negative 69. Means the output, the second row, the output is negative 69. Negative 69. Yeah, be careful. We have two negative 69, okay? And what's the
5 and 9.
5 and 9. So two inputs, okay? Yeah, for this output, we have two inputs. That is okay. That is okay. We only require a function for each input. There's only one corresponding output. But for output, there might be more than one input, right? Remember, we just need a discipline and husband. So you write 5, 9. You have two inputs. When the input is 5, output is negative 69. When the input is 9, the output is also negative 69. So be careful. Yeah. Sometimes you might not careful and then you miss one. All right. Yeah, let's continue. This one. The function is given as a graph. All right. So you tell me what is f of 3. This time you tell me. I had a similar one earlier.
Positive 2.
Yes, exactly. Awesome. So we look for x equals 3 right here, right? And
Yes.
go up. Yeah, this point, I'm pointing this point. This point has x coordinate 3. And that point has a y coordinate 2. So the output is 2. Very good. Second part is different. Second part is to ask us to find the value of x such that y is 3, right? Yeah. It tells us the output is 3. Y value is 3. And what is x?
1.
1.
Exactly. You guys are great. So we look at y equals 3 is right here, right? And which point on the graph has a y value of 3? And this point I'm pointing. I have very big, the indicator. Yeah. And you go down, that point has x value of 1. So the input is 1. You guys great. Very good. Okay. So I think we covered a very basic for section 1.1, right? Input, output. And we covered a little bit vertical line tests. That is for section 1.2. And section 1.2 also cover one-to-one function. So there are a few minutes left. I'm going to explain what is one-to-one function, okay? A function is a one-to-one function. One-to-one function. If for each x, there is only one corresponding y, and at the same time, for each y, there is exactly one x. Okay, let's see. If we have a community, we have households here, right? And those households live married couples there, okay? And ideally, we want to, for each husband, only has one wife. And for each wife, there's only one husband, right? And that is a one-to-one. So if there's no cheating husband, no cheating wife, then the community is a one-to-one function. All right? Not only for each input, there's only one output. For each output, also there's only one input. Okay? Yeah, let's look at some questions very quickly. Yeah, very quickly. And to apply the definition we have just learned. This is the 5.1. I can go here and open 1.2. And our pre-quiz due soon, so make sure you are aware of the pre-quiz and get it done as early as possible, okay? Identify functions using graphs, this one. Let's just spend one. Okay. One-to-one function. Yeah. This is a graph. Okay, this is a good one. Which one is a one-to-one function? Which one is number 6? Okay, I'm going to show you this one. 1.2, number 6. 1.2, number 6. Okay, yeah, this one. R is a one-to-one function. As you can see, for each input, there's only one output. For each output, there's only one input. G is not one-to-one because for output 0, there are 2 different inputs. Like for the wife 0, she has 2 different husbands, so that's not good. It's a function, but it's not one-to-one. All right. And S is, yeah, as long as the relation for each input there's only one output, for each output there's only one input, then that is a one-to-one function. M is not because M has a cheating husband, right? For one input there's 2 different outputs. Yeah. So we run out of time. I want to show you a new module I posted in Blackboard. This is our essential. If you go to the 1483 course shop, on the very top, I added a module, new module, doing my homework assignments with Betty. If you click on it, so far I have 3 sections completed. I have the PowerPoints here. Each file corresponds to one section. So this is the 1.1, 1.2, 1.3. I'd recommend you try the homework assignments by yourself first. But when you just feel about, just feel you're gonna struggle, and you can look at my solutions. Maybe it will help you to make the job easier.
Thank you.
All right, guys. So I need to remember who was late today. We have Brandon, we have Emma, we have Noah. 1, 2, 3, 4, 5. So Kristen, Brandon, I already marked. Emma, Noah. Only 4 students. Okay. All right. So I'll remember to fix the attendance. Thank you guys for coming. I will see you on Tuesday. Have a good weekend. Feel free to email me if you have any questions. Okay.
Okay. Thank you.
Thank
Thank
you.
you for coming. Have a good weekend. Bye bye.
Thank you, you too.
For doing my homework with you, do we have to look through it and do it, or is it just something for us to study at?
Your voice is a little far away. Kristen, if you hear her, can you explain?
Does it have to do for doing my homework assignment with you? Do we have to do the that exercise, or are you wanting us to do it like use it as like a way to understand how to do it?
So which homework you need to do, right? So firstly, you need to do the pre-quiz. Do you have a plan when to take the pre-quiz?
I can take the pre-quiz in this room. This room is a protected area, and I asked the librarian.
Oh, it's proctored. you would have to go to a testing center.
Okay.
Yeah, I'm sorry. I think I posted an announcement about it. Did I? If the pre-quiz is a proper event, you need a so if you go to
Right there.
here, yeah, let's go to here. The pre-quiz should be here, orientation.
The pre-quiz has its
Yeah.
own little tab.
Mhm.
If you click on it, yeah, the instruction tells you that you need to go to a testing center. Yeah, once you finish the pre-quiz, you can start unit 1. Start work on this is introductions, yeah. And some link is just textbook, part of textbook. And
Okay.
some
It'll say
link,
ebook on it.
yeah. If you see the due date, yeah, whatever has a due date, that is something you need to work on.
Okay.
All right. I hope I'm clear.
Yeah. It's just I'm new to the building, so I'm still trying to look around, figure out.
I agree. Yeah, this is very different. Yeah, feel free to email me. So I'll see you guys on Tuesday.
That's
Yes.
Okay, good luck
See
for
you
the
on Tuesday.
quiz. Okay, bye-bye.
Bye-bye.
All right.